This is the voiceover for historical context or the history of epidemiology. Some of this material is also covered in your Merrill textbook, so there'll be a little bit of overlap. Hi, so this is the word epidemiologist has three main word parts from the Greek. Epi meaning upon, demos referring to people, and ology meaning the study of. So the question is, the epidemiologists are studying what subject or what is it that they are looking at that is upon the people. So the actual definition of epidemiology is given here. It's concerned with distribution and determinants. First of all, those two words starting with the letter D, distribution and determinants. And it's of both health and disease, of morbidity and mortality, of injuries and disabilities. And I'm sure we could add other things to the list. Nowadays, we want to add behavioral health concerns as well as physical health concerns. So epidemiologic studies are applied to control health problems in populations. So realize that this slide is old. It's going back to a 2009 H1N1 influenza. And now that we are in the middle of the COVID-19 pandemic, this seems very old. But I think that in a simpler way, it illustrates the point. It gives some facts on the slide, and if you read them, you'll see that it's concerned with the words, what has happened, when and where did it start and spread, why did this outbreak occur, and that answer isn't exactly on there, what precipitated it, how was it spread, and how it was controlled. So we get the what, when, where, why, and how questions. That are all part of an epidemiologic investigation. As I mentioned, epidemiology is concerned with both determinants and the distribution of health events. So I'm going to start with discussing these determinants of health events. What's causing things to change in the health of a population or an individual. The second aspect of the study of epidemiology, and that's the distribution. And this isn't just locality, but that's certainly one of the things to consider. It is also looking at what age groups, what people groups, what ethnicities, what occupational groups. How are these health events being distributed among the people? The next element of epidemiology is, of course, the population. Since epidemiology as a science examines disease occurrence among population groups, it's not focused on what's happening at the individual level. Because of that, it's often referred to as population medicine. The next element of epidemiology is, of course, the population. Since epidemiology as a science examines disease occurrence among population groups, it's not focused on what's happening at the individual level. Because of that, it's often referred to as population medicine. This slide presents a list of the types of health phenomena that epidemiologists may study and may consider that are affecting the population. Note that they're not always negative. Sometimes I think we're always searching for problems, and we forget that populations have strength too. They have different levels of health, and one of the things that epidemiologists can consider is, why is one population or one age group or one geographical group staying healthier than another? Note that in this course, in your population health paper, you will be collecting health statistics, and you will be looking at all of these things in bulleted points, and you will be comparing it with a specific Chicago community that you've chosen, compared with the city of Chicago as a whole, or maybe another community within Chicago, and even some national statistics in order to determine what the level of health or the concern is for the community that you've chosen to write your paper on. As you look at this slide and consider health issues that are of an interest to you, make sure that you include behavioral health, social health concerns, dental, nutrition, chiropractic concerns, or other things that I have not mentioned. It is certainly important to know what the purpose or the objective of the science of epidemiology is. So I list some things here. These 4 verbs: to describe the health status of a population is often part of a descriptive study. To explain the etiology of disease or predict the occurrence of disease is often a more in-depth analytical research study. And both of those can be helpful in controlling the occurrence of disease. The first point here is that epidemiology is an interdisciplinary field. So professionals from many disciplines contribute to the study of disease or health among the people. And you can see a list of these particular disciplines on the slide, as well as the following slide. The first point here is that epidemiology for an epidemiologist to determine the level of health or the concerns of certainly assaults or insults on the health of a population, it will require that they count the number of cases often, and that they translate those into rates so that these rates can be compared. So that counting is part of the term quantification. It helps the investigator to describe characteristics of time, place, and person in that health concern. One of the greatest responsibilities that the public even demands of people in the science of epidemiology is to determine whether an epidemic or some form of it, such as a pandemic or a localized outbreak, might be occurring. Epidemic is defined on this slide as the occurrence of cases of illness clearly in excess of expectancy. So in order to determine whether an epidemic is occurring, you would need to know what the usual frequency of a disease is. As you know, influenza is endemic in these northern climates for months. And so the question is whether an influenza virus has gone epidemic because it has exceeded what we would expect for the winter months in this northern climate. This line graph is a good example of what I just spoke about. So what we've got here is the rates of mortality related to pneumonia and influenza from 2007 to 2012. So you can see the seasonal inflections as we expect here in the northern climate. And the black lines then would indicate what would be a normal endemic pattern of pneumonia and influenza. But the blue line reflects the excess, where it's peaked way above what we would expect in early 2008, for instance, early 2010, a little bit less so, and early 2011. Those would be of concern to the epidemiologist. After I've laid this foundation, the title of this PowerPoint was Historical Aspects of Epidemiology. So I'm going to briefly go through a few slides in far less detail than is in your Merrill textbook. So epidemiology began with the ancient Greeks, and back then they had very little scientific foundation of disease, and so their understanding is that disease was related to the wrath of the gods, or a breakdown in religious beliefs, morality, and if not, then it was related to weather changes. After having laid a brief foundation, Hippocrates is considered the father of medicine. We will find out later that there is another gentleman who's considered the father of epidemiology. But Hippocrates was the first one who noted that there could be a scientific basis for the presence or absence of disease. He wrote a thesis called On Airs, Waters, and Places, and this was about 400 BC. So he suggested that disease might be associated with the physical environment, which we now know to be true. He wrote about the dangers of parts of the environment. So I'm just going to read this a little bit. This is straight from his thesis on airs, water, and places. Whoever wishes to investigate medicine properly should proceed thus. In the first place, to consider the seasons of the year. Then he goes on to talk about the winds, whether they're hot or cold. He considers the quality of waters, which we know to be important. He considers the behavior of persons, including the inhabitants and strangers. He considers the water that the inhabitants use, whether it's marshy, whether it's unfit for cooking. He considers the ground, the mode in which inhabitants live. What are their pursuits? Are they fond of drinking or given to eating in excess? So you can see that there's a foundation for a lot that we now consider important when we investigate disease occurrence. One of the earliest epidemics, and certainly one which we still shudder with fear, is the bubonic plague. Occurred in the 14th century, and it claimed 1/4 to 1/3 of the population of Europe, spread along trade routes. There's a YouTube video clip here that you might find interesting to view. You can stop at 2 minutes. One of the next epidemic is cholera. You can read about it here on the slide. I mentioned Dresden, Germany, because the next slide talks about how grateful they were that even though this epidemic was spread along this trade route through Europe, for some reason, Dresden, Germany was spared from this deadly cholera epidemic. I'm going to come back and discuss this disease again in about 5 slides, mentioning the efforts of John Snow and how important that was for him to isolate the fact that there was some kind of a microbe that couldn't be seen by the human eye, but was in the waters that was causing this disease. Next epidemic. So this is a fountain that you can see in Dresden, Germany. Again, the citizens had this built because of their gratitude and relief that the cholera epidemic seemed to skip their population. If you look at the top of the fountain, there are some turtles hanging over the top there, if you enlarge it. And that is because it's been found that the bacteria, Vibrio cholera, can actually colonize the shells and intestines of some turtles. And that's why they were put in the fountain. This slide is beginning to look at 6 different men and what they contributed to the field of epidemiology. As we've already mentioned, one of the important tasks for epidemiologists is counting. John Grant was one of the first. He began by recording the births and deaths in England. He also noted the seasonal variations. He determined infant mortality, so deaths of infants under the age of 1, and gender differences. He was one of the first ones to use quantitative methods in describing population vital statistics. Because of that, he is known as the Columbus of biostatistics. And one of the most famous and helpful things he did at that time was to determine what were considered the 10 leading causes of mortality during his lifetime. They'll be presented on the next PowerPoint slide. So here you can see those 10 leading causes of death during Grant's lifetime. In this bar graph, some of the names of the diseases have changed over time. So for instance, consumption was basically pulmonary tuberculosis. Strangury was intense pain with urination. Flux was a name for bloody diarrhea, and dropsy was a name for heart failure. Second scientist is Edward Jenner. I'm sure you're probably familiar with him since he was the first one to actually create a vaccine against disease. And as you know, he started out with a cowpox, using a little bit of cowpox and then inoculating it into a person, as will be described in your Merrill textbook. John Snow was an English physician living in London, and during the terrible cholera epidemic, what he did is he began a process of creating a map where the homes of persons who had died of cholera were marked with a black spot, and so it's called spot mapping. And he was able to determine that the worst cases were where the families were getting their water from the most polluted part of the Thames River. Because of his efforts, he's considered the father of epidemiology. You can read this slide about John Snow's experiment, and also I would recommend that you look at the YouTube video below. You can stop at 5 minutes, but it will really give you a good understanding of how he did it. And then I also, in the notes section, I mentioned that mapping can still be done today, only now we use computer software. And I mentioned that there was an American Legion convention in Philadelphia, and they were able to use mapping software to follow the persons who had attended the convention back to their destinations, and then determine that the polluted water was related to cooling towers at the convention. Fourth contributor is Ignace Semmelweis. He was a clinical assistant in obstetrics and gynecology in, I believe, Vienna. What he noticed is that the laboring mothers had higher rates of infection if they had been cared for by a medical student than if they had been cared for by a midwife. And he was able to determine that he believed, again, something not seen by the human eye, which was just so unusual back then, for them to even conceive that there would be a microbe that you couldn't see with the human eye. But that it was on the hands of the medical students because they had been working with cadavers and the midwives had not. And this was the first time that they actually introduced the practice of of an agent that could kill that invisible microbe as well, and that was using chlorine. William Farr was helpful in a couple ways. First of all, he developed the foundation of what we would consider the ICD-10, or the system we've got for codifying medical diseases today. And secondly, he was one of the first ones to begin to study mortality rates, both where people work and as well as looking at how where people live in terms of the density of the population, how that might impact death rates. The final single contributor to our understanding of disease historically was Robert Koch. He was a German microbiologist, a physician in the late 1800s. He was the first to verify that human disease was caused by a specific living organism. Up until then, they knew there was something in the water, on the hands, for instance, something causing disease, but they didn't know what the particular microbe was. He developed 4 postulates of disease to determine whether the disease was caused by a specific microorganism. His postulates are very famous, and basically all of these are requirements that must be met in order to draw a conclusion that that specific microorganism caused that specific disease. So please read these postulates before you leave this slide. The most famous pandemic historically until COVID-19 here was the 1918 influenza pandemic. Killed 50 to 100 million persons worldwide. The case fatality rate was reported to be 2.5% for that particular influenza pandemic. And I put in the notes section a link where you can actually compare what the current case fatality rate bar graph is for countries around the world. You might find that interesting to compare this to that case fatality rate back in 1918. This slide considers more recent applications of the science of epidemiology, including the Framingham Heart study, as well as a study that finally concluded in 1976 that smoking was related to lung cancer. What's interesting about this one to me is that it was 2 British doctors, Dole and Peto, who were both cigarette smokers themselves, the beginning of the study that made this conclusion. I put in a YouTube video clip there that you might want to look at. I think it's really interesting how they came about and determined that there was not just a strong link, but there was actually a causative relationship between cigarette smoking and lung cancer. I mentioned earlier in this PowerPoint that epidemiologists are not concerned only with infectious diseases, but also chronic diseases and conditions that are affected by our lifestyle and by the impact of health promotion or the success of health promotion messages. So one of the things that they look at is the relationship of the built environment in encouraging or dissuading persons from active exercise. So built environment might be a new term for you. Instead of it being the natural environment, like the qualities of the air, the ground, the water that Hippocrates mentioned, the built environment is the impact of things that persons have built that can impact how much, how well, and what kind of active exercise a person might have living in that community. Another concern might be the relationship between cultural practices that affect behavior. Those cultural practices may include rituals, dress, such as notions of modesty, the handling of emotions, how do different cultures handle emotions, or the degree of focus on individualism versus community.